All right, so here with APS team today, we got service going, and we're going to be doing a quick tutorial over gas heat staging specifically. We'll do a quick intro into just single stage heating initially, and then we'll lead that into some more advanced second stage heat and just kind of see where the class goes from there. This video brought to you by Air Performance of Central Texas, serving your commercial needs since 2012. All right, so let's start with just our basic sequence operation for gas heat. Can you name it to me? What's our very first thing that happens?
Use a draft motor.
Okay, we call for heat. Call on W, and then we call for inducer. Okay? What is the inducer trying to do?
Negative pressure or check the pressure.
Negative on what?
On the drafting inducer? Is that what you're talking about?
Yeah, what is the...
It triggers a negative pressure switch.
On what? What are we triggering that vacuum on, the negative pressure?
On that gas? On the gas?
Nope. Heat exchanger.
Heat exchange.
Oh, okay.
Or more specifically, the combustion chamber.
Gotcha.
Okay?
Gotcha.
So we induce draft on combustion. I'm just gonna go with that chamber. Okay? So, what closes at that point?
Negative pressure switch.
Yeah.
Pressure switch. Okay? Pressure switch closes, then what?
Your igniter switch.
Okay? But now we start talking about
The blower.
igniters.
Yeah.
How many types of igniters do we see commonly today? There's really
3?
You got the spark igniter, glow igniter,
And the pilot?
and the standard pilot.
not standing pilot. Not today's world.
I still see some, but
So, well, right. So it's not that we don't see it at all. So if we want to get real technical, there's 4. What's the fourth?
Spark, electric, glow.
There's the
You're right. We have spark,
Yeah, spark. Got the glow,
hot surface,
hot surface.
HSI.
Yeah,
We've got pilot.
What's that fourth one though?
It's a hybrid. Remember?
It's called a what?
It's a hybrid system.
Hybrid system.
So what out of these would make a hybrid?
Probably that spark and the hot surface together.
Spark
No.
and
The pilot.
The spark and pilot. It's called an intermittent pilot. So what happens with an intermittent pilot is the pilot shuts off every time the heat does. But what we do is the spark ignites the pilot, and then the pilot ignites the flame.
Gotcha.
It's a 2-stage ignition.
Gotcha.
Okay? So we got interim pilot. If my spelling is off, you just gotta live with me. I did not attend the spelling bee in school. Alright, so inducer closes, or inducer engages, pulls on combustion chamber, pressure switch closes, confirming that we have induced a draft. Then we initiate, and this is where, depending on which one of these we have, depends on what happens first.
Got a question. So just say, for instance, there's a crack in the heat exchanger. Will that not let that pressure switch?
100%.
It will?
So, it may or may not.
Okay.
It depends on, like he said, where it's at, and how big it is, how many there are.
Gotcha.
So a huge test I've done, and my preferred method of testing heat exchangers is I take a charcoal barbecue lighter.
Okay.
And what I do is I turn the fan on high, and then I run that igniter, or the lighter, in each chamber. And what I'm looking for is I'm looking for that flame to either flicker or go out altogether. If I see either of those happen,
It's got to crack.
that chamber's got to crack.
It's got to stay at.
Yes. What I want to see, a past test, is I put that flame in there, it doesn't do anything at all.
Okay.
Okay?
Gotcha. That's a good way. Okay.
And y'all know as well as I do, it takes very little air movement to affect those tiny little lighters, right?
Right.
So, and if you're in a spot where it's hard to get to, I've seen guys try to do it with cigarette lighters. Well, you just can't always get in there.
You ain't gonna be able to get in there.
You get that long stick on that grill lighter, and it works great. I had a tech show me that, years ago, right when I first really started getting heavy into the trade, and I've practiced that ever since. I keep 2 or 3 lighters on me just for that purpose. That's all I use them for. Sir.
Those are for ones that are hard to access where you can view the tubes, right? That's the test that you would use for that, other than that, a visual inspection.
Well, so I do recommend the visual, but that lighter test, whether you see it or not, you can do that test without having to do the visual. Now, if it's an RTU or something, we can still get a visual. 100%, please do. But one of the things we've got to start to differentiate here is, depending on which one of these we have, depends on what the sequence happens next. Okay? So, with a hot surface igniter and the pilot, these fire first. Okay, well, obviously the standing pilot is always going to be lit, but it's there before the valve ever opens, right? If the valve, without that pilot running or without that HSI preheating first, the valve's not going to open, right? Mm-hmm. Whereas, same thing with intermittent. Whereas with spark, many of the spark systems, the valve will open for a second, and then the spark will hit. So depending on which one of these you have, depends on what happens next. So once this pressure switch closes, and it has to close for a set period of time.
Yeah.
So this is where you come back into the ICM. What is our ICM?
The board, right?
The board.
It's the board. What's the term for it?
Ignition.
Control module.
Control module. Ignition control module. So, that's what we're looking for there, is all this is reporting back. So I just want to make that differentiation. Okay, they're going to do different things depending on how they're designed.
Gotcha.
So let's say, what's the most common out of these we see?
The spark.
HSI.
Okay, you see more spark, you see more HSI. What about you guys?
Me?
Yeah.
Standing pilot, because I was working on stoves before.
Okay.
Works the same way.
So I do agree with the spark.
Yeah, on the RTUs, I mean, that's all you're gonna see. I haven't seen a hot surface igniter on them, but like I say, yeah, I see a lot of the spark ignition. Yeah.
These two
Are the most
are
common.
the two that everybody uses today. You only really run into these on old equipment. Why did they even do the intermittent pilot to begin with? What do you think? What was the point of it?
I'm not sure on that one. I know what you call it still use it a lot. Carrier uses
So you didn't
that.
always have an open flame? Would that be like more of a like the LP side of it? I mean,
No.
No,
gas.
LP. Yeah,
Well, I know
LP.
gas after, but I'm saying.
Well, see, the LP, all you're doing is you're changing only the orifices
Like
in the,
orifice on
yeah.
that.
That's all you're doing to convert that.
In some cases, also the spring.
Oh, in the spring, yeah, in the spring, in it.
So, really, in my opinion, the main reason why they did this was because of either one, they're trying to be different, and two, you had old school techs only knowing this
Gotcha. So they made it easy.
and having to come over to this.
So, that's what I was thinking too. Why they made them like that, so that way you have to only go to that certain maker for that certain gas valve. You know, a lot of people can't make that type of gas valve.
Right.
So that's what a lot of I've seen a lot of manufacturers do is when they're making these parts to where only they can sell them instead of these other.
Yeah, that's exactly right. Because if you have a pilot of either type of pilot, what also do you have to have built into that valve? You know. Because
It's gotta have
it's not just a
actuator or something there, right? Or
It's
similar.
you get the concept, but what has to be in that valve? There's a very specific component that you don't have to have with these two. It's built into the valve. No.
It's got like a pilot hole for it's like it regulates a little bit of pressure rather than the full blown open or close.
Yes, that's part of it. It goes even further than that.
Sorry.
No, you're right though. So yes, as part of the answer is it has to have the pilot tube, first of all. But there's a second thing that's really crucial as well to that answer. And you have this.
I mean, all of them have spring loads. There's all spring loads.
A thermocouple.
There you go.
It has to have a thermocouple built in. Do we know what a thermocouple is?
Yes, sir. That's what senses that flame. So the flame, once that reaches a certain temperature, it's similar to the flame sensor, but this is
on the
instead
actual
of.
valve, you said?
Yes.
Yeah, so that goes right there in the actual flame, and once that sensor, then it'll open it up to release the gas to ignite it.
Right, and it'll hold the pilot.
Correct.
That's its job.
Oh,
So that's where, like when you have a pilot, you gotta hold the button on the valve until the thermocouple heats up.
Yeah.
What that is doing is that pilot flame putting heat to the thermocouple is actually generating a small charge of electricity.
Gosh.
And that small charge of electricity energizes a tiny little coil. Yes, that could be part of it. Honestly, it's not been something, I'm not going to sit here and act like I've done extensive research as to why they do that. One of the things I do think that was a contributing factor was the transition of skill sets. There's lots of things you'll see, especially when I see in the 2000s lines of equipment, is they were really kind of trying to upgrade to more new age technology, but there was still a lot of old age techs, and everybody was trying to catch up, right? So they had to design the equipment in such a way to where those techs could follow along, because it's just such different. There's units out there today, they don't even have a contactor. It's literally a control board with a relay that runs the compressor. And that relay goes out in the control board, you're looking at a board.
Yeah.
So anyway. Yes, so thermocouple, like I was saying, the heat from the pilot heats up the thermocouple, which generates a small charge, which then that charge trickles into a tiny little coil inside of the valve, which activates the pilot valve inside of the main gas valve, right? We tracking? And it allows that pilot to stay lit. And so that is all built into a pilot type systems valve. It's not just a regular valve. You won't see that on a hot surface or a spark ignition only. It'll just be a valve where its only function is to flow gas through. Right?
Yeah.
Where a pilot system, that valve has multiple jobs. It's not only to flow the gas for the burner assembly, it's to also maintain the pilot light. Okay. So like I said, with these, the ignition is going to light before the valve. With a spark, typically the valve will fire before the spark. So you'll go ahead and you'll get some air, and it's not an extensive amount, it's just a very short, small burst, gets enough gas in there so when it fires it can light.
So, I know for sure on the spark,
Yes.
The gas releases, but on the hot surface igniter, I thought that right there, once it reaches, gets so hot, then the gas releases.
Yes.
Yeah.
Right?
Yes. And they've got it timed.
Okay.
So on hot surface igniters, it's all based off of time. They know that after so many seconds,
Oh,
that
okay.
igniter should be
Gotcha.
hot enough. And depending on the manufacturer, they'll tell you, yeah, there's some of them are like an 80 something volt system. I think it's trained, maybe, that if it's supposed to be 80 volts to the igniter with it plus or minus a little bit, and if it's outside of that, either there's something wrong with the igniter or there's something wrong with the control board. There's some real specific ways of kind of tuning that in.
Right.
So anyway, but yes, that igniter's got to heat first, and then the valve fires. Okay, so I'm not going to focus a whole lot on these two because not that they're not there at all.
Correct.
They're just very limited. Almost everything nowadays is going to be this. If we were working residential, it might be a little different, but we don't. Okay, getting back to our sequence. We call for heat. Inducer pulls or vacuum on the combustion chamber. Our pressure switch closes, which again, this is a negative pressure,
Mm-hmm.
right? Then if we have a spark ignition, the gas valve opens for a split second, and then the igniter starts to fire, right? If we have a hot surface, then we fire the igniter, give it 10-15 seconds to preheat, and then we open valve. Okay? So then valve opens. Jinkity in. So once valve opens, what are we looking for next?
Flame sensor.
Flame sensor. How many types of flame sensors do we see?
I think there's one. Huh? Well, two. You got the thermocouple, and then you got the just the regular flame sensor on it.
The vast majority will be
Like that. Just,
an actual flame rod, right? And so there are some out there, especially when you start dealing with boilers, that they'll say they're a hot surface igniter or something along those lines. They will use the igniter as the flame rod.
oh wow.
You don't see that very much on smaller equipment, but you do see it on some of the bigger stuff. And so that hot surface igniter is your flame rod. So let me not get ahead of myself. Valve opens. We look for flame. Okay. So what happens when the furnace fires up, runs for 30 seconds, or probably it's really not even that long, runs for 20 seconds or less, and then all of a sudden the flame just drops out.
Typically, it got that carbon built up on that flame sensor, to where you gotta sand it down, so it's not sensing that flame.
Yeah, exactly.
What do you want to use to clean that?
Sandpaper. That's what I use, sandpaper on it.
My recommendation is a $1 bill.
$1 bill?
$1 bill. You heard that before?
Mm-mm.
So the metal on there, I forget exactly what it's made out of off the top of my head, but the metal on here is made of it's a polished metal, okay? Whenever you take actual sandpaper to it, it will definitely clean it for the moment, but you take off a lot of that finish. And when you take that finish off, it corrodes tremendously faster. So that's what you want to be careful of. And one of my old professors taught me this trick. You take a $1 bill and just use a $1 bill. $1 bill has just enough abrasiveness to take a lot of that buildup off without actually doing any real damage to the finish on the sensor. And great, it's not like a new sensor, right? But it's a lot better than using a really coarse, sandpaper or something like that to try to take that buildup off. So I do recommend using a dollar bill. If all you got is sandpaper, it's all you got, right?
Any paper will work, like,
It's true.
especially if you're too poor and don't have a dollar.
Yeah.
Use your debit card.
But yeah, I would suggest shying away from actual sandpaper. Because what you don't want to see is you don't want to actually see this get scarred up. Because when it starts to actually get scarred, that sensor's not going to go very far. And you're going to have the same problem. You'll be right back there having to replace it or try to clean it again or something like that.
I think this thing's out of memory.
Already? That's okay. All right. We still rolling?
Mm-hmm.
So, valve opens, we sense flame, now what?
Blower turns on.
Usually 30 to 90 seconds, we engage blower. What happens if the blower doesn't turn on?
Then it's gonna trip the high limit switch.
I live there.
Yep. Making sense so far.
Yeah.
Okay. This helpful? Okay. All right. This is all for just first stage. Everything here, you get no heat at all if this don't happen. Especially with RTUs, one of the most common things I see on the induction motor is critters, specifically birds. That's why a lot of times you'll see some kind of cage on them. But I've seen a lot of birds get in there. I've seen mice get in there. Anytime that happens, even if it's habit side, like the discharge side of that induction motor, it will still cause you're still not moving enough air through it, right? Because it'll sense it either way.
Correct. Even dirty filters will even cause that high limit switch too.
Yeah, definitely. Well, and like I said, if we don't pull enough draft on that heat on that combustion chamber, we don't fire.
Yeah.
It just sits there and this sits there and runs and runs and runs and runs until it finally just locks
Shuts
itself
itself down. Yeah.
And so, any idea what this is? So there's your motor.
That's an ECM motor. Is that what it is?
ECM? No. Any idea? It's okay not to know. This is a centrifugal switch. Okay? What that is, and we can tear this apart here in a bit, but there's a switch in here that as this motor runs and ramps up, the centrifugal motion of the rotation causes the switch to close, like a relay. And it's the mechanical motion of the motor that energizes the relay. Okay? And so once that closes, this is confirmation back that that motor is running. Or it could run through other safeties. Your part of that pressure switch safety could be tied into the centrifugal switch on the motor, to where even if, say that this pressure switch failed, got stuck, something like that, and the motor quit working, and the system didn't realize the switch opened or didn't open, say the switch didn't, then when this slowed down because it's not running anymore, it's going to open, and it's another layer of protection to shut the heat down. Because what happens if we run without this induction motor?
I mean, that carbon monoxide and all that won't go out, so it's probably gonna ball down, right?
True, but
Would that heat exchanger get hot?
No, it's gonna blow out when you're gonna hit your rollout sensor.
yeah.
Mm-hmm.
So at that point, you get rollout. When this
Rollout.
stops working, or if it fires, if it fires without this running, you will have a rollout scenario. And I have seen entire systems catch on fire because of rollout.
Man.
Because, you know,
Still going?
the most common scenario was either the rollout switches weren't functioning properly, which happens, or somebody had redone a bunch of wiring and all the wiring was too close to the burners and it got hot, and it happened just fast enough to melt those wires and start an electrical fire. And sure, the rollout switches did their job and they killed the flame, but they didn't kill it in time. And you went from a gas fire to an electrical fire and burn an entire cabinet up.
Yeah.
I haven't seen that very many times, but I have seen that a couple of times. So that's why, you know, it is important to be mindful. You know, you don't want anything around that burner assembly that shouldn't be there. Before we go too much further, there is a distinction that at some point we might need to make. Do we want to get into talking the difference between 80% and 90%, or do we want to move on to stage 2? Y'all tell me.
I'm okay without it.
Do we even know what I'm talking about between 80% and 90%?
Yeah, the BTUs on it. No. Well, I know the 80. Well, factor of it is 80% and 90%. So the 90. I know the 95% are the
Let's get into it.
water.
Yeah.
Well, you know, they gotta have the PVC drip leg.
Yeah. All right, so there's two primary types of systems out there that we deal with today on gas heat. Working my technical difficulties. And you have an 80% furnace or a 90%. The number one way of telling them apart is a 90% furnace will have a drain coming off of the
PVC.
combustion chamber. Typically, they'll have a drain coming off of the induction blower. And like he's saying, the actual flue pipes will be plastic. The induction blower housing will generally be plastic instead of being the metal. If you walk up and everything in there is metal inside that housing, and there's no extra drains anywhere,
80%.
you very likely have an 80% furnace. But if you walk up and you see any plastic, the blower housing's plastic, the flue pipe's plastic, any of that nature, PVC, you've got a 90% furnace. Okay? The difference is, much like it says, that 80 or 90% is an efficiency rating. Okay? So we'll throw an example. Let's say we've got a 100,000 BTU furnace. Okay? A 80% furnace, even though it's rated at 100,000 BTUs, only 80,000 BTUs actually makes it into the space. That other 20,000 goes through the flue pipe and has no functional use. Right? Obviously, at 90%, it's literally 90% of your heat created of that 100,000 actually gets used in the space. What they do to accomplish that is they install a condensing heat exchanger into the combustion chamber. Okay, there's an actual condenser built into it, and it literally condenses. So gas, specifically what we deal with the most in the city, same thing happens with LP though, has a lot of water in it, right? Just naturally, it's part of the chemical compound. So one of the side effects of burning it is we separate the liquid form of the gas when we combust it. We separate those molecules out, okay? And water is just very superheated to where it's still a vapor. When we run it through that second heat exchanger, we take so much additional heat out of that gas that that water cools down enough to turn back into liquid water. Okay? And so that is why, so typically another sign of an 80% versus 90% is an 80%, the burners will come into the bottom and the inducer will be up top. Typically 90% are reversed. Your burners will burn in from the top and they'll pull the flame down, and your inducer will be at the bottom of the heat exchanger.
With a drain line? Correct?
Yes, with the drain line. For that very reason, we need to capture all that water that's getting collected in there. And so that's how we have to do it. And that's where it becomes very critical that that system has a proper trap on 90%, because without that proper trap, you won't be able to induce a draft. Right? Because that trap and that P-trap is creating a seal to allow a vacuum to be pulled on that combustion chamber. Whereas without a P-trap, that induction motor is just pulling air straight through the drain pipe. Okay. So those are the common differences we need to pay attention to. It's especially critical with a 90% furnace that it's level, or specifically has a slight tilt to the drain. I had a system, it's back when I was still doing residential. They did the install, and when they installed it, they did not properly level it, and it had a slight tilt back to the far back corner away from the drain. What ended up happening was the system would run sometimes for a day or two, and then all of a sudden kick out. And we'd show up, troubleshoot it, and we kept having this repeat issue. I think I ended up personally having a callback on this 3 times, which for me is a big deal. 1 time is bad enough. What I ended up discovering was I put my level on it and I found the pitch issue. What it was doing was all of that condensate coming off of the gas was collecting in the back corner. And the only way I caught this, I sat there and watched this unit run for 4 hours. Yeah. And in that time frame, I started hearing the induction motor start to gurgle because it was having water get in on the squirrel cage. And eventually those louvers had so much water in there that it ended up, it couldn't move any air. It literally blocked all the airflow. So that was what was happening. The water would build up inside the heat exchanger until it got to the blower or the induction motor. And then the water would plug up the induction motor, which has a drain on it. It just couldn't drain fast enough. It's a very small drain. It's not meant to handle that entire heat exchanger's water load, which is basically what it was being asked to do.
Yeah.
So then it would trip out on the pressure switch because we were no longer pulling a vacuum, and it'd shut off. And it would do that once the water built up. It would do that enough times where at three strikes you're done, lockout. Right?
Yeah.
And then we'd get the service call, we'd come out, locked out on safety, turn it on, start to troubleshoot it. You'd sit there and watch it for an hour or two. It'd run perfect, no problems. The only way I found that was to sit there and once I heard that, then it cued in my head, hey, I should check the level. Once we leveled the unit,
No issue.
problem completely went away. The unit's not had a problem for the last I'm aware. It was several years ago, but that fixed the issue up to that point. It was purely based off the level. So actually that unit is the reason why I carry a torpedo level in my tool bag nowadays. I did not do that prior to that unit. So anyway, leveling is very important with a 90% furnace. Otherwise you will have calls like that you rip your hair out. And that's one of the first things I check on those systems when I walk up to them. Okay. let's get into the second stage of that. Okay? There's multiple ways we can have a second stage. Do we know them?
Same way we just added the first wave,
Okay?
where you just can trigger a completely different valve, induction motor.
We have a multi-valve setup. Okay? What else? Alright, that's alright. We have either a multi-valve, meaning we've got multiple burner assemblies, multiple manifolds. They're all running different, independent of each other, but once they're on, they're all full blast, right?
Yeah.
Okay? And this is more of the old school method. You know, you're gonna see that the most with older equipment. I'm talking 20 plus years. Stepping up from that, the next version above that is a multi-step valve. So with this valve, it's got a couple of connection points coming into it, right? So it's no longer just a 2-wire turn me on and let me go, right? It's just favorite kind. It is an actual, with this, you'll have a first and second step on that valve, so depending on which set of wires you fire. And typically, not always, but typically, when you see a system like this, the induction motor will actually be a multi-speed motor as well, if it's not ECM altogether. But usually with a multi-step valve, you'll have a multi-speed induction motor, so it runs slower at the first stage valve, right? Then when the valve is stepped into high fire, so you have low fire, high fire, right? When the valve gets stepped into high fire, the induction motor ramps to high fire. Typically the sequence there is the induction motor will ramp first, and you'll have two sets of safety switches. You'll have a low fire switch and a high fire switch. And so what it'll do is it'll go through the normal startup and it'll fire everything in low fire first. Okay? Then once you call for W2 or high fire, it'll ramp the induction motor up, prove on the high fire safety that we're for sure pulling enough induction, and then it will step up the valve.
Have you seen some where on a single unit it has its own like 2 separate valves and 2 separate inducer draft motors as well, or no?
Yes. So when you have a multi-valve setup, you basically, that's what you'll see.
Yeah. So, but on the because I know you were saying the induction, the inducer draft motor, it's basically like an ECM, and it's kicks up and ramps it up. But have you seen one, 2 inducer draft motors and 2 gas valves?
Yeah, that's the top one he was talking about.
Yeah.
You'll have the same, basically our first sequence of operation that we had the first time, it just has a separate heat exchanger, and it's doing the exact same thing again.
Yeah,
but
but
it's just on a W2, so.
No, I understand that, but I'm saying he said the induction motor, which is the inducer draft motor, is a single one.
That's for the second.
No, he said it's a single one though, right?
Well, so on the multi-step,
Yeah.
But the multi.
No, the valve. That's the valve.
right? The valve is a multi-step valve.
Correct.
So
But the
it
inducer draft motor
is a single motor.
is single, so
So-
you're never gonna see 2 of those. Is what you're saying?
On the second process we're talking about.
On this same heat exchanger, okay? So when I'm talking about a multi-step valve, it's literally one valve body.
Oh, so yeah.
It's not 2 valves, because
Okay.
with 2 valves, then you're talking about a multi-valve setup.
Yeah, that's what I was on. Well, that's what I'm asking, because it was 2 gas control valves on it. It was totally separate on the same unit, on a Linux one. So that's why I was saying.
And it had a single induction?
Yeah.
Yeah.
So that's what I was saying. But have you ever seen one with 2 inductions, or it's just
Yes. That is a variation of these 2 kind of combined.
Gotcha. Okay.
Right.
Okay.
So, yes. 100%.
All right.
And my expectation would be that induction motor was either ECM or multi-step.
I want to say, yeah, because when you're talking about it, it did ramp up. That's why I was like, but I seen 2 gas valves on it, so it did, you know, that's why I was asking, have you seen one with, 2 induction motors rather than just that one with the ECM?
Right.
With-
I
with
think I've
gas?
seen the Linux.
Yeah, that's what I was saying. I was working on a Linux, and it definitely had the two gas valves.
Well, and you got to keep in mind, too. So, the most effective way for this is there are several design types. Everybody's got to have their own.
But it's the same method, though,
It's the
correct?
same methods, and they use the same principles, just like the intermittent pilot. Okay.
Yeah.
Somebody had to say, "I'm different." I mean, it's what it is.
Yeah.
Because what do they run into? They run into patent wars, right?
Yeah.
Everybody's battling over patents and who owns this, who owns that. I'm this, you're that. So what that does that throws us 1,000 curveballs because they all got to do it different. But these are the principles that they base that off of. So yes, that you saw it.
Yeah.
And that is the case.
Okay.
Like you said, so it sounds like that motor was probably a multi-step, not ECM. There's a difference.
Gotcha. Okay.
So, multi-step valve is one valve body with multiple steps to open inside the valve. Depending on which coil we energize inside that valve depends on whether we fire low fire or high fire.
Gotcha.
Good?
Yep.
Okay. The next one is a modulated valve. Okay? So with a modulated valve, you will have an ECM motor with that valve. And I'm expecting we're going to see a lot more of this as time goes on. Yes.
My question on the modulated ones, your motor's ramping, gas valve stepping up, does it also work with our VFD controlling water? Is that also stepped the same way, or are they all a certain percentage with water flow?
So when we start talking boilers like that, what you're talking, the pumps are going to be controlled a couple of ways. The most common is DP. But with DP, doesn't matter what the boiler's doing. The boiler is just responding to the loop load. The pump responds to loop load based off of valve positioning. So very common today, we're no longer using 3-way valves. Everybody's trying to go to a 2-way valve setup. Understandably, it is more efficient in my opinion. But you've got to be able to ramp your pumps now to accommodate those valves closing water flow off completely. If everything was 3-way valve, your DP has very little fluctuation. But it causes all kinds of crazy issues on things like your boilers or your chillers. So, yeah. So the pumps are not going to correspond to the boiler necessarily. They're going to correspond to the loop pressures.
Same principle as your chiller.
Yes. Yep, 100%. That makes sense? Okay. With these setups, these other stages, all of this is going to work within that same sequence of operation, just with slight variations. Right? Because with a multi-valve, you just go through the exact same fire process. You just have a second heat exchanger and a second set of valves to deal with. Most of your valves today are not only valves, they're also pressure regulators. Okay? There is a difference. A lot of your older school systems, you will see 2 look like valves in there, but they're not. One's an actual valve, one's a pressure regulator. But the systems they design today, they have combined that, where one valve is doing the job of both. So, If you see that, I don't want that to trip you up with what we're talking here. And you'll always know that because they'll be, if it's a valve and regulator, they'll always be in series with each other on the pipe. If it's a multi-valve for multi-staging, they'll be parallel to each other. Make sense?
Are our scopes with, especially the older ones where you have a regulator going to a newer unit, is it within our scope to be working on those regulators or replacing those regulators, or is it, I guess it's up to the customer?
For boilers?
For RTUs, for instance,
Okay.
like at Goldsmith, we had a regulator that was constantly bleeding out,
Yep.
and it was only one out of the entire roof that continued to bleed out, so I just turned the gas valve off
Right.
and let them know, but wasn't sure whether that would be under our scope, because it was a brand new RTU that had, it's a new one that you don't need a regulator on.
Right.
So just trying to figure out whether that's part of our scope or someone else's.
As in replacing,
Or retrofitting where you would use it, yeah. Let the customer, whether we have a problem with it, told them we can fix it or.
yeah, so the gas valve, yes, that's within our scope. Our scope begins where we terminate gas at the unit. Now, when we start talking
Anything after
all the
that?
way, the piping itself can get a little gray area between us or a plumber, depending on exactly where you're working in the scenario and if it's roof or in a space, all that good jazz. You start to see some gray area there, whether a pipe fitter or a plumber should be running that or whether we should. For sure, no matter what, we stop at the building main.
Yep, I know we stop at the other side of the gas valve, but we can turn it off.
Yes, and really and truly, that's always going to be your safe bet. That isolation valve there at the unit,
Mm-hmm.
that's always going to be your safe bet. If you're not sure of your scenario, don't go past that point. Because at that point, even if you needed to go past that point, a lot more involvement has to happen. Because now you've got to worry about trying to drain that entire piping and you're talking about bleeding it. That is something I recommend. If you have a flame that's not firing, before I start touching anything on the igniters, unless it's a spark igniter, that's kind of obvious, you can hear the spark, right? But if it's a hot surface or a pilot or anything like that, just because you hear the valve clicking open, doesn't mean you have gas there. The biggest thing, what I do is I listen to see if I can hear the flow. If I don't hear flow, I try to see if I can smell. And if I'm sitting there trying to fire and it won't fire. If I don't, even if I hear it but I don't smell it, more than likely you're not actually, you got a bunch of air you got to purge, typically in that scenario. You need to go back, find a union or something somewhere, or if they don't have a union somewhere, you just got to sit there and keep redoing it, redoing it. Sometimes there'll be a test plug on the valve or the regulator. You can take out with an Allen and bleed it right there at the valve there, and then just put that plug back in.
Yeah, we had that same scenario at Goldsmith Building D. They had all the RTUs dead, and none of them were getting heat. And so me and David H went out there and we couldn't smell nothing, we couldn't. So we sat there and we bled it for 5 minutes on each one, and finally you start smelling it. And boom, as soon as that smell, then the unit came on. So we did it all individually, but we didn't mess with anything behind all that.
Now, did that answer our questions on multi-stage gas heat?
Yes.
Okay. Does it make complete sense? Is it still a little fuzzy? Good.
Well, now that you break down all the
Different types.
different patterns of robots, it makes a lot more sense now. Because now you know where to look.
Yep. Okay. I would say, if you think of any more questions, we can definitely talk about them. Let's break this motor down, and let's take a look at that centrifugal switch. It does have some springs in there, so when I pull it apart, it may kind of at us. But let's see what it looks like inside. So this is our ECM that is opened up. This is just the back of the cover. Pulled off, nothing in there, nothing fancy. So what we're dealing with is you've got these little mechanical arms that swivel. And so as this motor ramps speed and begins to run, these arms swing out and they cause this plunger to pull down. And you can hear that switch trigger, and that is the centrifugal motion of the motor rotating that's causing that. And so these arms pivot in and causes that switch to trigger, and that's all it is. It's just a little bitty tiny relay that triggers whenever once it gets pulled down on the trigger, and that's it. It's just confirming that this motor is running at a proper speed, and it's all set up, by the factory to do so. Typically, you're going to end up replacing the motor if one of these ever fails. In my experience, it's not very often that these do fail. It's just every once in a while. Vast majority of the time, the motor or something else will go out long before this switch ever does. Any questions?
No. So does this work as a brake, or is it reading how fast it's going? Is that what you're saying?
So as it turns, the centrifugal energy that is created forces the mechanical motion.
Gotcha.
So these,
Okay.
you see these bigger armatures on the bottom? Those swing out. And because those swing out, because it's spinning with so much centrifugal force, it forces it to pull down on that switch,
Gotcha.
causing it to trigger. That's really all it is. Yeah, very, very simple setup design. So whenever you're testing it in there, like I said, it's going to be open when it is not running. And so it's going to have to get up to full speed before it actually closes.